Hey everyone, in this quick video, let's look at the 4 to 1 multiplexer, tiny but powerful, very powerful part of a digital circuit. So, what does a multiplexer do? Um, a multiplexer selects one input from multiple inputs and sends it to a single output line based on control signal, also called the select line. As I said earlier, this is a 4 to 1 multiplexer. So we've got four inputs and we have two select lines. So let's dive deep into it. It has four inputs though, but it only gives one output at a time and controlled by the control signals that we have here. Actually, there are two. So I'll be using this application, that's the logism evolution, for a small simulation. So this is like a simulation for a multiplexer using the inverter, the AND and the OR gates. Yes. So the control signals can someone can also say it's like an inverter. You see the inverter symbol here. So here all the inputs are zero. But I see the inverter has inverted all the inputs here from 0 to 1. So you see the lines they are active. Good. So that means if a line is active or a logic gate is active, you see that one of these lines will be active. One of these lines will be active and this will be active too. So let's look at it. Good. So let's start from S0. So when S0 and S1 has an input of 0, the output will come out of I0. This is a three logic gate, so it's all or nothing. So either the three lines are all active, or no input will be sent. So let's see. We said it will take an input from the output to come from I0 because we take the logic gate here. This line and this line is active, remaining this. So if we input here, you see it's on now, it's all active. So it sends the input to the OR gate here for it to be outputted. So that's how it works. So as the input is being sent from here, all the others are blocked. So no input will come from the others. Okay, so let's deactivate this one. So when S0 is still 0 and S1 is 1, let's see something. S1, you see, when we inputted, we made S1 1, this line deactivated. And let's see which line activated when S1 was S1 was made 1. So this line was going to I3 and I1. So now these two are active, remaining one. That's this, and it connects to I1. So if you activate I1 to send an input from I1 to be outputted here. So when S0 is 0 and S1 is 1, the input comes out of I1. Let's see the reverse of it. Thus, if S0 is 1 and S1 is 0, let's see, two lines are active here. So we activate I2, its inputs here, and make this one active to be outputted. So the output will come out of I2 when S0, sorry, S0 is 1 and S1 is 0. So what if all of them, all of them is 1? Let's see, S1. So when all of them is 1, come here, then see, good. The output will come out of I3. So we activate I3, then see this line is active to have the output. That is how it basically works. So, the multiplexer is like a traffic light. You see, um, when one light switches to green, the others stays on red for some minutes or for some time, which is being controlled by a microcontroller or something. Then it comes back to red. So basically, this is how it works. If the selector approves of one, like this, see these lines are active. So just need this for the input to come out of it. So it works basically like a traffic light. Okay, so this is how a multiplexer works, and it's simple and smart and super useful in computers. Okay, so this is basically how it works. Thank you for watching, and if you have any questions, put it in the comment section. I'll come and answer it for you. Thank you very much. Have a nice day.